So unit 4, so there is lightning and switching over voltages. Okay, first we have to discuss charge formation in the clouds. Different types of theories are there. Based on different types of theories, we have to discuss how the charges are takes place in the cloud. Okay, so here, and the lightning phenomena is a peak discharge. Lightning phenomena is a peak discharge in the charge accumulated in the clouds. Discharges into the neighboring cloud or to the ground. Okay. Lightning phenomena is a peak discharge in which the charge accumulated in the clouds discharges into the neighboring cloud or to the ground. Okay. So the electrode separation that is called cloud to cloud or cloud to ground is very large. Okay. Cloud to cloud or cloud to ground is very large. So generally, approximately that is called 10 kilometers or more. Okay. The mechanism of charge formation in the clouds and their discharge is quite complicated and uncertain process. Okay. A lot of information has been collected since the last 50 years, and several theories have been put for the explaining the what of this lightning phenomena. So there are different types of theories are there. So based on theories, we can understand the concept of how the charge formation in the clouds. Okay, charge formation in the clouds. These are the different types of theories explain how charges formed in the cloud. Okay, so Wilson theory, Simpson theory, Reynolds theory, Mason theory. By using these theories, we have to understand the concept of charge formation in the clouds. Okay, so here, so Wilson theory is only assumption based. So Wilson theory is only an assumption based, but the remaining theories are some related to our practical conditions. So by taking these some assumptions, this theory was explained by the Wilson scientist. Okay, okay. So in this charge formation in the clouds, during thunderstorms, positive and negative charges become separated by heavy air currents. Okay. During thunderstorms, positive and negative charges become separated by the heavy air currents, which ice crystals in the upper part of the rain, upper part, and rain in the lower part of the cloud. Okay. So for example, this is the cloud. In this cloud, the ice crystals are present on the upper part of the cloud and the rain in the lower part of the cloud. Okay. So here, the factors that contribute the formation of or accumulation of charge in the clouds are too many uncertain. Okay. But during thunderstorms, positive and negative charges become separated by the heavy air currents. Okay. During thunderstorm, positive and negative charges become separated by the heavy air currents. Heavy air currents. Understood? Heavy air currents, which is ice crystals in the upper part of the cloud, and rain in the lower part of the cloud. Okay. So the charge formation or charge separation is depends upon the height of the cloud. The charge separation depends upon the height of the cloud. So which is range from 200 to 10,000 meters. Otherwise 0.2 kilometers to 10 kilometers. The charge separation depends upon the height of the clouds. Okay, which is a range from 0.2 to 10 kilometers. Understood? So with their charge centers probably at a distance of 0.25 to 2 kilometers. That is called approximately 300 to 200 meters, 2000 meters. That is called 2 kilometers. Understood? And the value of the cloud that participate in the lightning flash over are uncertain, but the charge inside the cloud may be as the charge inside the cloud may be 1 to 100 kilocoulombs. Fine. The charge inside the cloud may be as high as 1 to 100 coulombs. Okay. Clouds may have a potential as high as 10 to the power of 7 to 10 to the power of 8 volts. Okay. clouds may have a potential as high as 10 to the power of 7. Understood? That is 100 megavolts to, so 1000 megavolts, 10 to the power of 7 volts to 10 to the power of 8 volts, with the field gradient range from 100 volts per centimeter to 10 kilovolts per centimeter, with field gradient ranging from 100 volts per centimeter to the 10 kilovolts per centimeter. It's clear. The energies associated with the cloud discharges can be as 250 kilowatt hour. Okay, it is believed that the upper region of the cloud are usually positive charged. Upper region of the cloud is positive charged, whereas lower region of the cloud is predominantly negative. Okay, except the local region that is inside of the cloud. Okay, near the base and the head of the head, which is positive. Clear. The maximum gradient reached to the ground level due to charge could may have as high as 300 volts per centimeter. Okay, the energies associated with the cloud discharges may be very high. Clear. So this is different types of theories are explained. This is about some introduction regarding to the charge formation in the clouds. So first we have to concentrating on how the charge formation in the clouds according to the Wilson theory, first theory. So upper region of the is positive. This called cloud. In this cloud, upper region of the cloud is called positively charged, and the lower region of the cloud is called negatively charged. And the local region are near base head positively charges like this. Okay, this is called field gradient to the ground. Okay, so here first we have to concentrating on Wilson theory of charge separation. Then after that, Simpson theory and Reynolds and Mason theory. First, this Wilson theory is only on assumption based. Wilson theory is only an assumption based. It is based on only assumption. So, okay. So a large number of ions are present in the atmosphere. Large number of ions are present in the atmosphere. In this atmosphere, so large number of ions are present. Okay. So many of these ions are attached themselves to small dust particles and water particles. Okay. Large number of ions are present in the atmosphere. So then many of these ions are attached themselves to small dust particles and water particles. It's clear. So a normal electric field exists in the atmosphere under fair weather conditions, which is generally directed downwards towards the earth, like this. The electric field is present in the atmosphere, is generally downwards toward the earth. This is called electric field. Electric field is generally downwards toward the earth. Okay, a normal electric field exists. This is called electric field. Normal electric field exists according to this theory. Normal electric field exists in the atmosphere under fair weather conditions, which is generally directed towards the downwards towards the earth, like this. The electric field is downwards toward the earth, according to the Wilson theory. Understood? So the intensity of the field approximately 1 volts per centimeter at the surface of the earth, and it decreases gradually with height at 9,500 meters. It is 0.02 volts per centimeter, according to this Wilson theory. The intensity of the field is approximately 1 volts per centimeter at the surface of the earth. Okay. So relatively charged raindrops of 0.1 centimeter of radius, relatively large raindrops of 0.1 centimeter radius. Falling the field becomes polarized. Okay, falling the field and becomes polarized at the upper side of acquires negative and the lower side is called positive, like this. This is in the raindrop. This water drops. This is a raindrop. Water drops. Upper part will become a negative charges, and the lower part of this raindrop will be will acquire as a positive charges. Okay, the relatively large raindrops falling the field. This field becomes polarized. Okay, this upper side acquires negative charges, and lower side of the water drops will become positive charges, like this. So then the lower part of the drop attracts the negative charges in the form of atmosphere charges from the atmosphere. Okay, then the lower part of the drop attracts the negative charges from the atmosphere. So that's both positive and negative charges which are mixed up and then are separated like this. Okay, so this is about according this charge formation in the cloud according to the Wilson theory. Okay, so then coming to the Simpson theory. Okay, so according to the Simpson's theory, there are three different types of regions present in the cloud. Okay, so this is called, according to the Simpson's theory, there are three different types of regions. So in the cloud, this is called A region, this is called B region, this is called C region. These are the three different types of regions present in the cloud, according to the Simpson's theory. Understood? So in this theory, below region A, in the below region A, air current travels above 800 centimeters per second. Air currents, this is called air currents. This is air currents. Air currents travels above 800 centimeters per second, and no raindrop fall through. No raindrops fall through. The below air region, so the velocity, that is called speed of the air currents, is called nothing but 800 centimeters per second below air region. So here, this is called air currents. Okay, the speed of the air currents is nothing but 800 centimeters per second. This is the speed of the air currents. Okay, and in region A, air velocity is high. In region A, in this region A, so below A, region A, 800 air current speed is nothing but 800 centimeters per second, and in region A, air velocity is high enough to break the falling raindrops, causing positive charges spray in the cloud. Fine, understand? In region A, air velocity is high enough to break the falling raindrops, causing positive charges spray in the cloud and negative charges in the air. Like this, the positive charges spray in the cloud in this way. Okay, from the region A. Okay, so below region A, the air velocity, air current velocity is very high. That is called speed of the air currents is called 800 centimeters per second. And then in region A, the positive charges spray into the upper part of the cloud. So like in this way. Okay, the positive charges are spray into the upper part of the cloud, and the remaining charges are placed in the air. Okay, so the spray is blown upwards as the velocity decreases. The spray is blown upwards. As the velocity decreases, the positively charged water drops recombine with the larger drops and fall again. Understand? The spray is blown upwards as the velocity decreases. The spray is blown upwards like this. So the spray is blown like this upwards. Then velocity decreases. The air current velocity decreases. The spray is blown upwards, and then velocity of air currents decreases. The positively charges water drops recombine with the larger drops and fall again. Okay, thus the region A becomes positively charged like this. This region A will become positively charged, and region B becomes negatively charged by air currents. The region A, the region B is become negatively charged by air currents. Right. So in upper region of the cloud, this temperature is low. In upper region of the cloud, this is called upper region of the cloud. This temperature is very, very less. So here in region A, so only 0 degrees Celsius. So that's why only raindrops are present. Okay, raindrops are present in this region A. So in region B and C, okay, minus 10 degrees and minus 20 degrees. So in the upper part of the cloud, the temperature is very, very less, below minus 50 degrees Celsius, below minus 40 degrees Celsius. The upper part of the cloud is having temperature is called minus 40 degrees Celsius. Okay, below minus 40 degrees Celsius, that is called minus 50 degrees Celsius. That's why the upper part of the cloud is called ice crystals present in the upper part of the cloud. Because of this temperature present on the upper part of the cloud is less. So because of this region, the ice crystals present in the upper part of the cloud. Ice crystals present in the upper part of the cloud. Fine. So upper region of the cloud is temperature is low and only ice crystals exist. In upper region of the cloud, the temperature is very, very less. That's why the only ice crystals exist in the upper part of the cloud. This is about Simpson theory. According to the Simpson theory, these charges are separated like this here. In this above region C, so positive charges are accumulated in the cloud, and here negative charges are accumulated, and here positive in the region A, positive charges, and here negative charges. Okay, the impact of the air on these crystals make them negatively charges. Impact of the air on the crystals is become negatively charged. The distribution of charges within the cloud like this is separated like this charges. Upper part of the cloud is called positive charges, and here lower part of the cloud is becomes negative charges. Okay, So this is about according to the Simpson's theory, the charges are takes place in the cloud. Charges are formed in the positive charges and negative charges are accumulated in the cloud. So like this. This is about Simpson's theory. Then next coming to the Reynolds and Mason's theory. Reynolds and Mason's theory. According to this theory, thunder clouds are developed at a height of 1 to 2 kilometers above the ground. Thunder clouds are developed at heights of 1 to 2 kilometers above the ground level. Okay, and then they go up to 14 kilometers. Understood? According to this theory, thunder clouds are developed at heights of 1 to 2 kilometers above the ground level, and they go up to 14 kilometers. Okay, and the temperature is 0 degrees at 4 kilometers. That's why there is no ice crystals present at this 4 kilometers of the cloud. So the temperature is only 0 degrees Celsius. That is why the only raindrops present, and may reach to minus 50 degrees at 12 kilometers. Minus 50 degrees Celsius at 12 kilometers from the ground. From the cloud is having distance from ground to cloud, there is a distance of 12 kilometers. That means that the ice crystals are present in the upper part of the cloud, according to this theory. Fine. So water droplets do not freeze at 0 degrees Celsius. Okay. So the water droplets do not freeze at 0 degrees Celsius, and freeze only when the temperature is below minus 40 degrees Celsius. Okay.